Hey everyone, today we're going to look at the mean value theorem for derivatives. So eventually we're going to see one with a different thing called an integral, but right now we're just looking at the mean value theorem with derivatives, which is what we've been studying for the past couple months. So the mean value theorem, it's a theorem, so there are going to be some preconditions. The first condition is that the function is continuous and the function needs to be differentiable. So if f of x is not both of those, mean value theorem does not apply. And then it says on AB, remember this is an interval. It's not an XY point, it's an AB. These are both X values on the number line. It says, then there exists a C value such that f prime of C is equal to this. Okay, so this, we've seen this before. This is average rate of change. So all it's saying is that f prime is equal to the average rate of change. That means on some interval, if we were to take the average over some interval, then there's somewhere in it where the average is actually what the rate is. So find the average rate of change of the rock from 2 seconds to 4 seconds if s of t is equal to that. So that's my position. So I want the average rate of change or average velocity. So all I need to do is take s of 4 minus s of 2 all over 4 minus 2. And I don't feel like plugging that in by hand, so I'm going to use a calculator cheat. I'm going to plug this into my calculator with x's instead of t's in y1. And then I'm going to say 4 store x, and I'm going to do alpha trace. So that's alpha and then trace, and I did that into y1. So I get negative 96 when x is 4. So negative 96 minus, and the bottom will be 2. So then I'm going to set 2 to x. I'm going to plug in y1 again. 116. Find the average rate of change from 2 seconds to 4 seconds. So if this is concerning you at all right now, just remember that sometimes things can be going down. So it didn't give us units beyond seconds, so I'm not going to be like units per seconds. So let's see. That's just a reminder of how we did average rate of change. So we're going to do some examples. So given f of x is equal to 5 minus 4 over x, find all values of c on the interval from 1 to 4 such that the mean value theorem applies. So all this is saying is that we want to find the average rate of change, so f of 4 minus f of 1 over 4 minus 1. So f of 4, I'm going to use the same trick I used before because I really just don't feel like typing stuff in. You know, I'm going to do my table for this instead. Table is going to be even easier because I can change my independent to ask. So I can then plug in 4 and I can plug in 1. So that's funny. Okay. So it's when I plugged in 4, I got 4. I did a double take. I was like, wait, if I plug in 3, do I get 3? No, okay. It's just when you plugged in 4, you got 4. And when you plugged in 1, you got 1. So you got 3 over 3, so you got 1. So that is equal to our average rate of change. It says find all values of c, so the mean value theorem applies. That means f prime of c is equal to that average rate of change. When is f prime of c equal to 1? Well, I need to find f prime then. Let's see, so f prime of x. Well, the derivative of 5 is 0. And then remember that this is actually saying minus 4x to the negative 1. So when we multiply that by the negative 1, we get 4x to the negative 2, or 4 over x squared. And so then we can go back and we can say, okay, we got to solve this. 4 over x squared, when is this equal to 1? So multiply both sides by x squared, get 4 is equal to x squared. And then we can take the square root of it and get x is equal to plus or minus 2. Now we need to be really, really careful. So I solved and I got an answer. However, my interval goes from 1 to 4. So I can't use -2. I can say x is equal to 2. That's the c value. Because -2 is not between 1 and 4. All right. Let's look at what that means really quick. So if I look at this graph, then I'm going to set my window. I'm going to go from 1 to 4. So if we look at the average rate of change, that's connecting here and here, right? So the average rate of change connects the two endpoints, and it says, okay, the slope between those two endpoints, that's the average rate of change. The mean value theorem says somewhere else, it turns out when c is equal to 2, wait, yeah, okay, so I drew this a little bit wrong. There's the x-axis. Here's 1, 2, 3. Here's 4. So when x is equal to 2, the slope of the tangent line is the same as that average rate of change. Those lines are parallel. So all right, our next example says, given f of x is x cubed plus x squared minus x, it's written a little bit small. We want to find c, we want to find when does it actually equal the average rate of change from -2 to 1. So again, I am not interested in doing this by hand, so I'm going to do this out. I don't know what I was, okay, so anyway, I don't feel like doing this by hand, so I'll go into my table and I'll just, let's see, -2 and 1. Again, that is so silly. Let me just make sure I actually plugged it in. Okay, I did actually plug it in, all right. So f of -2 minus f of 1 over -2 minus Canfield. Like technically that would still work, but that's not what you're supposed to do. F of b minus f of a. All right, I did the bottom the same way. 1 minus -2, silly. All right, so then we get 1 minus -2 over 1 minus -2, which is, it's going to be 1 again. But this is equal to f prime of c. And we're going to solve for c. So when does 1 equal 3x squared plus 2x minus 1? Remember, because that's our derivative. And so now I need to solve. 1 equals 3x squared plus 2x minus 1. So I'll start by subtracting the 1 from both sides because it's a quadratic. And to solve quadratics, we want things to equal 0. So then I'll try to factor it.
Wait, did Pete talk to you already?
Hold on 1 second, computer. Yeah, that was Braxton. Okay, let's see. So 3 times -2, -6. Let's see, 3x, x, the plus will be here, the minus will be here. 3 minus 2, no, that's not going to work. 1, 2, 6. Okay, so I'm seeing I can't factor this, so I'll just go to the quadratic formula, plus or minus, let's see, -2 plus or minus the square root of 4 minus 4 times 3 times -2 all over 2 times 3. So then we got what? -2 plus or minus the square root of, it's 12, it's 24, so 28. Oh, yep, that's why it didn't work. So if I'm going to simplify the square root of 28, that's 4 times 7, and I can take the square root of the 4 and get 2 root 7. So I can say -1/3 plus or minus root 7 over 3. I am not 100% certain that they're both going to be on or off the interval, so I'm just going to double check really quick. So let me see. -1/3 plus square root of 7 over 3. That is on my interval. Let's try subtracting that. That is also on my interval. So they're both on our interval, and we're good. All right, next one. Find the c-values on 1 to 6 for this function. Okay. Now I'm going to think about this function as being 4 times x minus 3 to the -2, because the derivative of that's just going to be so much easier. And wait. We could do all the work for this and never realize something. The interval that they gave me was 1 to 6. One of our necessary preconditions is not met right now, and that is f of x needs to be continuous and differentiable on the interval. But f of x is discontinuous at x equals 3. So the mean value theorem does not apply. You're not supposed to draw the winky face. I think that's not a mathematical symbol. Let's see. A company finds an equation which represents the number of widgets. Yep, widgets. They sold for the first year. It is given by blah. Find the average rate of change in widget production during the first year. Okay, so this also has a t plus 2. It has a denominator with x in it, or with t in it in this case. We need to think about, okay, is the issue here on the interval? It says the first year. That would indicate we want t equals 0 to t equals 1. So this has an issue when t equals -2. That's not on the interval, so we're okay. So we want the average change in widget production for the first year. That'd be s of 2 minus s of 1 over 2 minus 1. Yes, you should write this out every time. If you make a mistake somewhere in your work, you are doing yourself so many favors by writing in what you're about to do. All right, yeah, I typed it in correctly. So now when I go to my table and I type stuff in, and I just go and I type in 2 and I type in 1, so 550 and 400, okay. 550 minus 400 for 2 minus 1. Like, that's all I need to show. I don't need to do any more than that. So, widgets per year. Find the date in which the average rate of change of widget production is equal to the instantaneous rate of change of widget production. Okay, so in the AP they wouldn't ask you find the exact day. They'd say how many days. They're not really concerned with you being able to do the calendar, but this is what the question asked, so I'm going to do it. So let's see. I want to know, when does 150 equal the derivative? And that, looking at that like that kind of scares me. So I'm going to distribute the 200 first and get the 1,000 minus 1,800 over t plus 2. And remember, guys, 1,000, this is saying 1,800 times 1 over t plus 2. This is a coefficient on a derivative thing. Another way we could think about that is saying it's 1,800 times t plus 2 to the negative 1. That's s of t. Since it's a coefficient on a derivative thingy, I don't need to like do product rule or anything. So s prime, well, that's just 0. And then here, the negative 1 times the negative 1,800 would be positive 1,800 times t plus 2 to the negative 2. Derivative of the inside is just 1, so I don't need to worry about it. So I could rewrite this as 1,800 over t plus 2 squared. That's s prime. And so remember, we want to find when does this equal 150? Equal the answer that we got from part A. So I'll cross multiply. I'll get 1,800 is equal to 150 times t plus 2 squared. Chop a 0 off both. I'm going to divide both sides by that number. And oh, cool, it's nice. So I get 12 is equal to t plus 2 squared. Some of you guys might be like, but Canfield, you said you always have to like distribute or like and say equal to 0, blah, blah, blah. Yeah, or since this is something squared is equal to a number, I could take the square root of both sides here and get plus or minus the square root of 12 is equal to t plus 2. And then I can say t is equal to negative 2 plus or minus the square root of 12. Square root of 12 is simplifiable, reducible, whatever. It's 4 times 3, so I'm going to write plus or minus 2 root 3. So now here's the thing. Negative 2 minus 2 root 3, that's before the start. That's a negative time, so that's not an answer. So we just say negative 2 plus 2 root 3. And even then, that does concern me just a little bit that it has a negative in the answer. So I'm just going to double check because I can. Sure. 1.464. Wait. Uh-oh. I did something wrong. Okay. I know I'm wrong because my time went from 0 to 1. I'm going to need to get rid of this part of the video. My time was supposed to go from 0 to 1. I went from year 1 to year 2 here. Golly gee. All that good work for nothing. All right, I'm gonna do it one more time. So we want s of 1 minus s of 0 over 1 minus 0. Okay, so then when I go in here and I do 1 and then I do 0, I get 400 and I get 100. So 400 minus 100 over 1, I get 300 widgets per year. All right, so 300 widgets per year. So now I want to find when is s prime equal to 300. So I got to find s prime first. So I'm going to distribute that 200. I'd really rather do that. And so I get so s of t, you are equal to 1,000 minus 1,800 over t plus 2. So when I take the derivative of that, remember that this is 1,000 minus 1,800 times t plus 2 to the negative 1. So that'll be negative 1,800 or positive 1,800 times t plus 2 to the negative 2. And the derivative of the inside is just 1. So I can say, when does 300 equal 1,800 over t plus 2 squared? So I'll cross multiply. T plus 2 squared times 300 is equal to 1,800. Then I'll divide both sides by the 300. So t plus 2 squared is equal to 600. Nope, just 6. And then I'll take the square root of both sides and get t plus 2 is equal to plus or minus the square root of 6. So t is equal to negative 2 plus or minus the square root of 6. So, which one is it? If it's negative 2 minus the square root of 6, then that's not inside our interval of 0 to 1. So it's not that. So it must be this one. There we go. So it's that much into a year. So t is equal to negative 2 plus the square root of 6 years. Normally that's where you'd stop, but they said we want to know, where is this in the year? So if we did that times 365, we'd be at day 164. And I guess we're into the 164th day. So take away 31 for January, take away 28 for February, take away 31 for March. Pretty sure March has 31 days. Yep. Take away 30 for April. And May, that's the other. No, May's also 31. Take away 31 for May. June 13th or June 14th. Something like that. Okay. And that is where I'm going to stop for now.